Okay, Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. I've been asked to talk about NLP, natural language processing. So basically to introduce what are the main aspects in NLP. So we'll be talking about the opportunity, what NLP represents as an opportunity. I've been asked to explain a little bit of the fundamentals of NLP, of natural language processing, and then we will move to the promises, what this is promising to us for the future. First, we start with the opportunity. One big opportunity is that we are digitizing the world. Okay, everything is turning digital. Currently, we have more than 5 billion consumers that interact day on, day out with the internet, with the data, and so on. By 2025, it will be 6 billion people who are producing data, information, and so on. The digital, what is called the digital universe, all of this data, which is textual, audio, video, images, and so on, is doubling in size every year. So we moved from, I can reproduce it here, from roughly 4.4 zettabytes, that is thousand of a billion, so it's 10 to the power 21 bytes. In 2013, up to here it's 44, it's 10 times, 44 zettabytes, and it is expected to move to 175 zettabytes very quickly by 2025. So we see that there is a huge amount of data that is produced. There is this picture which was released by EMC on the digital universe, by IDC, sorry, on the digital universe. And it says that if you consider the data in 2013 and the size of the data in this digital universe, if you consider a tablet, let's say it has some characteristics, but let's say each one can take 128 gigabytes. And you stack them up one on the other, you fill in some of this information from the digital universe, you would be reaching 2/3 of the distance from the Earth to the Moon with such data of the digital universe. By 2020, it will be 6.6 times, so 3 back and forth between the Earth and the Moon plus 0.6. It's a huge amount of data. And to give you a better idea, if you try to download the entire digital universe, which will be available by 2025, it will, supposing that you have an average speed of 25 megabits per second, which is considered as being the average in the United States, then it will take one person 1.8 billion years to download this content. It's huge amounts of content that we are producing. Now you are producing data. And if it were the whole world population, it would take them 81 days. And that is working 24 hours, 7 days, okay, non-stop. So, well, just to tell you that this is a huge amount of data. Let me show you this. If we consider what is being produced per minute in terms of this data, let's say the Weather Channel, 18 million answers to requests of weather forecasts per minute. Google handles something like 3.8 million searches on the internet every minute, and so on. We are sending almost 13 million texts per minute. We, the world population. YouTube, people are watching more than 4 million videos per minute, and so on and so forth. The numbers are mind-boggling. You will understand why I am mentioning these numbers. This is the opportunity. It's a lot of data that is available out there, and it needs to be handled. If you consider the digital universe in terms of what is known as the mature markets, namely North America, Western Europe, Japan, Australia. These mature markets were producing most of the digital universe of the content. It was more than 90%, say, in 2010 or just before 2010. And there are the emerging markets, Mexico, Brazil, China, Russia, India, and so on. And you see the trend that they are producing more and more of this content. And by in around 2017, it was 50%, and now they are overcoming in terms of content. What is the importance of this? The importance of this is that this digital universe is also multilingual. It's turning more and more multilingual, whereas English was predominant in terms of this content. Now it is also Chinese and Russian and Hindi and Portuguese and Spanish and so on. And we need to make sense of this, or we need to make use of this available data. So the second stop in terms of opportunities is the linguistic challenge. The linguistic challenge, the numbers tell us that, and I've been following this, and the size of the English content on the internet has been decreasing fairly steadily. It's something like the quarter of the content on the internet. For Chinese, it has been growing, obviously, and it's reaching almost 20% of the content of the internet. And, well, let me look at this. Arabic is barely 5% of this content. Unfortunately, this 5% of the content, of the Arabic content on the internet, is usually non-technical. We don't produce a lot of scientific, technical content. It's more newspapers, a lot of chat, and so on. But anyway, we are very isolated in terms of this multilingual content. A third stop, getting the IT out of its Middle Ages. What does it mean? We're still using, I don't know if we say mice or mouses. You're still using a mouse, you're still using a menu, you're still using a keyboard. I always tell my students, I used to tell them 15, 20 years ago, that we are still in the prehistory of computing, as long as we are using these aspects. Limited capabilities of search, that is, the search on the internet is not as we would love it to be. Very seamless, very semantic, that is, it understands what we want, it predicts what we want to search, and so on. Imagine having a secretary or a human assistant, and you are giving him or her a task of writing a letter to X or Y, and this person should know you by that time well enough to produce you. Just give some ideas, and that person, that secretary or human assistant, should be writing up the letter with your style, tests, preferences, and so on. We were still looking for systems that can handle our needs as well as possible. Well, maybe I'll skip some of these scenarios, but basically what natural language processing will allow us to do is to tackle some of these challenges. Tackle some of these challenges in making our searches more semantic. Tell me which team we are playing or is playing against us in the World Cup or whatever, who is us, in what circumstances, and so on. Dictating, giving your thoughts as I was explaining, and then the system will be producing a document in your own style with your own preferences, and then you just say, email it to my friends, and your friends, the word my friends would be understood, or whatever. And things like integrated translators, or like you're taking your phone, calling somebody in China or in Japan, you're speaking in Arabic or in whatever preferred language, and that person would be replying in his or her own language, and you would be just listening in your, I speak in Arabic, I would be listening the answer in Arabic, and so on. I'll be giving some example later. So these are major opportunities. A lot can be developed. You can dream just about it, and a lot can be done. The solution here is NLP in many parts of what I have been presenting for handling all this amount of data. What is NLP? It's a branch of artificial intelligence. The branch of artificial intelligence which deals with the linguistics, handling the language, trying to understand the language, trying to produce language. So the language meaning the speech or text. So both fall under natural language processing. It borrows from linguistics. Of course, you need to understand the language, computer science, mathematics, statistics, and it makes a soup, or a good soup, out of all of these ingredients. So we need to understand and generate natural language to make the use of technology as seamless as possible. It should be as natural as possible. To the common person, we should be able to use the technology without much of difficulty, just talking to this machine, and so on. Okay, I have been asked to go to some basic foundations to explain, okay, what's going on here under the hood. So I hope I do not get technical. I'll try not to get too technical. Well, when we talk about natural language processing, if I put aside the aspect of speech, there is one step here which handles speech, the phonetics. Then you have what is called lexical and morphological analysis. That is, basically you take the words and you try to dissecate to understand what is this word, which word it is, and how it is constructed. We know that words can have plural, can be feminine, masculine, verbs can have tenses, and so on. Syntactic analysis, that is the grammar, trying to check the grammar of the sentence. Semantic analysis, trying to make sense of a sentence. Okay, I'm giving a statement. What does it mean? What is the meaning of this statement? Pragmatic analysis means understanding a sentence, but in context. We do it naturally all the way. We're human beings. We want systems to do it also for us. Pragmatics, if I say, it's cold here, or let's say something will be, okay, it's cold here. Maybe the person in charge of the heating system would be turning on a little bit of the system. That's the pragmatics. What I said, it's cold here, or it's hot here. What is understood is another meaning, which takes into consideration a lot of things. And obviously, we want machines to get to these levels of understanding language. And finally, there is discourse analysis. Discourse analysis is trying to understand the construction of texts, the construction of dialogues, how the dialogues are flowing between a speaker, an utterer, and the other person. So this is the and then in terms of approaches to implementing these aspects, these modules, there are different approaches, and it's been almost historical. Rule-based approaches, basically we write rules that is if then else, the classical computer science if you want. And in order to write rules, you need to write exactly what is supposed to be done, and you need to be very expert to tell, okay, I want to understand a sentence. This is exactly how you do it, and you have to explicit all the rules that cover all of the cases. If you do statistical NLP, what you try to extract is statistics. It's just counting numbers. Numbers of what? Numbers of words. How many times did this word appear in a text? In fact, it's not just in a text. We take, well, I would say thousands, tens of thousands, hundreds of thousands of texts of different documents in a given language. And we count these occurrences. How many times did each word occur? How many times did the sequence of 2 words, of 3 words, of 4 words, and so on? Google is extremely good at this with their very huge servers and so on. They do a lot of this. And from them, you can be sure that we can learn a lot of things. We can predict, for instance, is this word correct here? Is this letter correct here? And we can correct things, for instance, one of the applications. Machine learning Techniques, obviously. This is a third trend in natural language processing. A number of techniques from machine learning, including neural networks and so on, have been used and are more and more used in order to solve the different problems of natural language processing. What are the challenges of natural language processing? I see them as three main challenges. Natural language is ambiguous by nature. Okay, I'll give some examples. And at the different levels, in terms of the speech, the phonological, the lexical, in terms of the words, the grammar, the meaning, and so on. Natural languages have fairly different alternatives for expressing the same thing. We may be saying the same thing, but in different ways, with different sentences, different wordings, and so on, which makes obviously the matter a little bit more difficult for a machine to understand and to generate, and so on. And a lot of content is implicit. I gave you the example that if I say it's cold here, there is some common knowledge that, okay, there are some politeness rules, maybe the person standing there would be turning on. All this knowledge, we don't express it explicitly. It is hidden in what you are saying. It's common knowledge between people. Just some quick examples. Ambiguity. If I say, I want to race, it can be, I want to race, I want a race, depending on my pronunciation, if it is good or bad, or which region of the world I'm coming from. I won in the past a race, I want you to race, and so on. Different analyses are possible here, so it is ambiguous. Words like to make can be used in the sense that, well, there are different words in terms of the phonology. The word make can be used to build, to make whatever, construct something, or to cook. I made a pizza, and so on. And as you understand, each word, different words have different analysis possible, and it is a combinatoric. There are a lot of combinatorics, and it makes the end result very ambiguous, and we need to handle this. I said there are different ways of expressing things in natural language. When you say, for instance, the question would be, could you please do it for me? And you get different possible answers to say more or less the same thing, of course with different nuances that the machine should grasp. One person could be saying, no. It's just a clear answer to, could you please do it for me? Another answer could be, I will not do it. It could be, I would not do it. It could be, I can't. I am afraid this will not be possible, or it will not be possible for me to do it, and so on. Okay, we are expressing different things. Of course, it has some more richness in what you are stating. Natural language contains a lot of implicit knowledge, as I was saying. For instance, a simple example, I gave the example of heating system. The monkeys were chasing the cats. We gave them bananas because they were hungry. And if the machine tries to understand, who is this them and they? Well, it could be the monkeys or it could be the cats, but it has some world knowledge that says cats don't eat bananas, as far as I know, right? So it would, on the basis of some additional knowledge that it has about the world, understand that, you're talking about monkeys and not the cats here. And so many examples can be given of these kinds of phenomena. And some other information. John woke up late today, his alarm broke. You have a whole picture of somebody waking up, the alarm alarm being used to wake up, or it doesn't, and so on. Okay, some of the fundamentals. Lexical analysis. Lexical analysis, basically we use some what are called automata. I think you're mostly from computing and so on. Some automata to analyze the words, like here, nice. So you go through different states to analyze, is this word acceptable or not in the language that I am defining? And you define a huge automata to analyze whether the words are or are not in a language. Morphological analysis, you basically try to dissecate the different words. You separate what are called the affixes, prefix, suffix, and so on, like immaterial, book, books, trying. In German, Sometimes it's both at the beginning. They're called circumfixes at the beginning. In Arabic, it can be even more complex. أَفَنُلْزِمُكُمُوهَا. It's a whole sentence. Shall we then force it upon you, or shall we then force you to it, or something like this? It's a whole sentence. The different colors showing different aspects of the word, of the sentence. It's a sentence, it's a word. Arabic has, as you know, the root and pattern. فعل, مفاعل, سعد, مساعد, مكاتب, and so on. Okay, so all of these are fundamental analysis that we need to do in order to do the very smallest natural language processing. Okay. I'll skip why need morphological analysis, spelling checkers, and so on. A lot of things can be checked whether they are correct or not once you do these basic language processing. I'll skip these things. It's how do you handle the morphology of a language? For example, if you have the word cats, we need to analyze that it is the word cat, that it is a noun, that it is in the plural form. This needs to be done. This is what is called the morphological analysis. It's extremely important. It's basic block if you're doing natural language processing. We use a slightly more complex structure or mechanism than finite state automata. They are called finite state transducers. So that basically, if you give it a word like foxes, and you work in this direction, it will tell you its analysis is that it's a fox plus noun and plural. And vice versa, it can work both ways. If you want to produce, now the machine is generating words written in the right form, it needs to go from this direction to this direction. Fox plus N plus PL, and it will tell you it is foxes. It's done through different stages. I will not get into the technical details of this. Those who know Turing machines, there is something similar to this analysis. Okay. In natural language processing, a lot is done also on what is called using hidden Markov models. Hidden Markov models are ways of modeling transitions. For example, here, that what is the probability that a verb would be followed by a noun? What is the probability of a noun being followed by a preposition? What is the probability of a preposition being followed by a verb or by a noun? And obviously you do it for all the kinds of constituents that you have in a language. Where do we get these probabilities from? From the corpora. Huge amounts of texts, and we analyze them, and we get these probabilities, and then we try to model the language on the basis of these statistics that we have made. And also, this is one type of statistics, and another one is what is called observation likelihood. The probability that a verb be this word, or that a verb be race, or that it would be the, which wouldn't make sense, it could be 0, and so on. So for each word of your dictionary, you will get also probabilities that it would have one, we call them tag, post tag, or another. And based on this, on these probabilities and these graphs that I have shown you, we try to find out what is the best analysis of a given sentence. And probabilistically, you will most likely be right, and you will be able to disambiguate possible if you have alternatives and so on. Syntactic analysis, you have different rules, for instance, to write a grammar, just like you would do for formal languages like Python or Java and so on. A sentence is a noun phrase followed by a verb phrase. These would be written by experts. Okay, so this is not the machine learning approach to natural language processing. But if you do machine learning, it's completely different. If you do machine learning, you might go back to these kinds of labels. You have a text with some labels, and you learn these rules automatically. I have a doctoral student who is working on generating such rules automatically for the Arabic language. That is, learning a grammar automatically. I'll skip these aspects. We have to worry about syntactic agreement. Is the sentence correctly constructed given the rules of the language? This boy walks is not correct, and so on. N-grams, I talked about sequences of words, 2 words, 3 words, 4 words, and Google does a lot of this, and this allows it to predict words, to generate, to analyze, and so on. NLP and machine learning, now it's a whole world. Supervised, unsupervised machine learning, you've heard about all of these throughout these 2 days. And reinforcement learning also is coming very strongly in the natural language processing. Reinforcement learning, as you probably know, is based on giving rewards if the machine eventually gets a correct answer, a correct decision, a correct analysis, or a penalty. And it improves based on that using some functions that allow it. Neural networks are a lot used. I will not retake what you have heard about very commonly these yesterday and today. Recurrent neural networks have initially been used a lot in natural language processing, well, the last few years. The idea is that recurrent neural networks there are different architectures and sophisticated architectures, but the basic idea is that you have some loop inside the system, so that this neural network can keep track of, it has some kind of memory. It keeps track of the words that passed before, and each time it has a new word. So it would be able, for example, to predict that, oh, this word is probably correct here because it has seen 3 or 4 words before it. So it keeps a memory of that, and these neural networks are quite powerful. Word embeddings is something extremely important. I'm looking at my watch because it's crazy. Word embeddings are extremely important, have been very important lately. Basically, it's just a vectorial representation of words. A word, like different concepts, a tiger, a panda, or whatever, would be represented by numbers, by a vector of numbers. How is it done? Neural networks are used to train on different corpora, different texts, and these words for each concept, for each word, for each verb, and so on, would be generated through learning. And then some similarity measure, some measure of how close a concept to another is calculated just based on these numbers that would represent the words. For instance, some of these word embeddings would tell you that the relationship between man and woman is the same as between king and queen. This is a classic example in word embeddings. And in another example, these same relationships also the same as between aunt and an uncle, and so on. So, promises, and I promise to finish fairly soon. NLP promises. There are all kinds of systems, NLP systems, which are quite amazing. For example, here, Somly, it has been developed by a young entrepreneur, British entrepreneur of 17 years. He developed this system that basically digests from different documents, news documents, and summarizes them into just one document. You have different documents, it summarizes the content into just one document. And it was taken over by Yahoo for $30 million. Sometimes you have multilingual, multi-document news digests. So from different languages, you digest, you translate, and you present in one language. Multi-document summarization, the same idea, and also multilingual. Neural machine translation, the use of some neural network architectures, whether they are recurrent or more sophisticated ones. Now we have, in terms of machine translation, the state of the art is that we are reaching, this is the human level performance in orange. This is what neural machine translation, it's basically, especially nowadays, basically the quality of machine translation, neural machine translation, has reached the quality of a human human level. For example, for some pairs like English, French, Microsoft said that in 2018 they reached human quality in translation between Chinese and English, and so on. Google's AI speech, I don't know if I can quickly. So if you hear this Spanish, in Spanish, the source. The sound?
Me pregunto cómo me sentía y creo que es cuando empecé a llorar.
Okay, that was a source statement in Spanish. I suppose nobody understands Spanish here. So here, the second, please.
I wondered how I felt, and I think that's when I started to cry.
Okay, this is machine translation based, speech machine translation. And then the third one.
Larry asked you how I felt, and I think it's when I started to cry.
Okay, please quickly, if you can do the first one and then the third, immediately one after the other.
Larry me preguntó cómo me sentía y creo que es cuando empecé a llorar.
Larry asked you how I felt, and I think it's when I started to cry.
What's the idea here is that the translation, it's no longer choosing if it is a voice of a woman, or it's a translation in the intonation of the original speaker. So the person who spoke in Spanish, they try to reproduce almost the same characteristics of the translation, and this was done by Google fairly recently in 2019. Well, different other applications based on natural language analysis, depression detection from the MIT, from dialogues, trying to understand if a person has some kind of depression symptoms, deciphering legal documents, the huge amounts of legal documents that are available that get analyzed and produced for you, and they can answer your specific case. There are some more recent architectures, very recent architectures, well, the last couple of years, for handling natural language processing. The transformer is one of them. This one, I'll say just this word and I finish. Just one word. This architecture was able to produce fake news to the point that the team that developed it said, we will not release the code because it's too dangerous. They just didn't know what are the possible implications. The fake news that it produced was so frightening that they decided not to release it. I'm sorry, thank you very much.